This is Algebra 2, Unit 5, Lesson 1, the rest of the notes on sequences. Okay, so the video left off on number 6, finding an algebraic formula for each of the following sequences. Okay, so what we want to look at is what formula, if we plug in an n value, will give us these values. So remember, the n value is the term of the sequence. So the first term is 4, the second term is 5, the third term is 6, and the fourth term is 7, and so on and so forth, dot, dot, dot. Okay, so we want to come up with a formula, a of n, that when we plug in n equals this number, we're going to get 4. Well, let's see. If I take each of these terms, let's see, 1 becomes 4, 2 becomes 5, 3 becomes 6. If I take my n term and add 3 to it, won't that give me 4? Let me see. 1 plus 3 is 4. 2 plus 3 is 5. Yep. 3 plus 3 is 6. And 4 plus 3 is 7. Yeah, that fits the terms of sequence. So for this particular one, if I took the sequence term number and added 3 to it, I get the term. Okay, let's try this next one. All right, we have 2, 4, 8, 16. All right, so remember we're plugging in n equals 1. All right, what's happening every time when we do this? When we go from term to term to term here, we're multiplying by 2, correct? So how could we use that to help us plug in a value of n1, 2, 3, or 4 to get these numbers? Okay, well, let's see. To get 1, when I plug in 1, I end up with an answer of 2. When I plug in 2, I should get an answer of 4. When I plug in 3, I get an answer of 8, and when I plug in 4, I get an answer of 16. Well, let's think about this for a second. Aren't these all multiples of 2? Couldn't I write this as 2 squared? This is going to be 2 to the first. 8 would be 2 to the third. And then 16 would be 2 to the fourth. So notice the n term right here, 1, 2, 3, 4, is actually the exponent on the 2. So I could say a of n is equal to 2 to the n. When I plug in the n value here, I get these numbers. If n is 2, I plug in 2 there, I get 2 squared, and so on and so forth. Okay, so your rule for this one is going to be a of n equals 2 to the n, and that gives me this sequence. Okay, the next one. This is n equals 1, 2, 3, and 4. All right, let's think about this for a second for a of n. What's happening every time? I plug in 1, I get 5. I plug in 2, I get 5 over 2. I plug in 3, I get 5 over 3. I plug in 4, I get 5 over 4. Well, what's happening every time? Well, you're taking 5 and you're dividing it by whatever n is. So this is going to be 5, technically 5 over 1. So this would be 5 over n, because this is 5 over 1 right here. So that would be 5 over n, would be my formula to give me that sequence. Okay, so that's some examples that we have. Let's try the next one. All right, this time, my first term, n equals 1. It gives me negative 1. When I plug in 2, I get 1. I plug in 3, I get negative 1. And I plug in 4, I get 1. All right, so that looks like every time I'm doing this, I'm getting a multiple of 1 when I do this. But what kind of 1? Well, if I do a of n, how am I going to switch between positive and negative 1s? Well, if I square them, aren't they going to be positive and negative? Yeah. So if I take, or whatever exponent I should say, if I take negative 1 and raise it to the n power, negative 1 to the first is negative 1. Negative 1 squared is positive 1. Negative 1 to the third would be negative 1, and so on and so forth. Okay, let's try letter E. This one's a little bit more complicated. All right, so this one, we go 10, 15, 20, 25. My first term is 10. My second term is 15. My third term is 20. My fourth term is 25. All right, so if I go from here to here, and here to here, and here to here, what am I doing every time? I'm adding 5. Okay, so I know I have to do something adding 5. Now, it looks like you say, oh, a of n equals 10 plus 5n, and that would work. But if and we think that would work. But what happens when I plug in 1 here? Is that going to work? No, because if I plug in 1 here to get this, I'm not going to have 10. I'm going to have actually 15. So if I plug in 1 here, I need this to come out to be 10. So instead of this being 10, what would it have to be? Well, it would have to be 5. If I plug in 5 times 1 is 5, plus 5 is 10. Let's see if that works for 2. 5 times 2 is 10, plus 5 is 15. Yep. 5 times 3 is 15, plus 5 is 20, and then it'll work. Okay, and this last one, for letter F, we have 1, 1 over 4, 1 over 9, 1 over 16. So we have n is 1, 2, 3, and 4. Now, how can we plug in an n of these values and get 1 over 1, 1 over 4, 1 over 9, 1 over 16? What do you notice about these numbers? Yeah, aren't these the squares of the term numbers? Technically, because this is really over 1. All right, so couldn't we write for this one a of n equals 1 over n squared? Yeah, let me see. This would give me 1 over 1 squared, which is 1. 1 over 2 squared, which would be 4. 1 over 3 squared would be 9. 1 over 4 squared gives me 16. So those are some of the ways that you could write a formula based on how the sequence goes. It's a little complicated when you have to write your own terms, but usually you can find some kind of formula to figure it out. This may not be the only way to do this, but this is just one way that it works. Okay, so which of the following for this exercise would represent the graph of the sequence a of n equals 2n plus 1 and explain your choice? Okay, so this is my rule for my sequences. So if I want to generate some terms for the sequence, for example, if I did A1, that means plug in the term value of 1, so this is going to be 2 times 1 is 2 plus 1 is 2 times 1 is 3. So this actually gives me the point when x is 1, y is 3. All right, what's the second term of the sequence? It would be 2 times 2 plus 1, which is 4 plus 1, which is 5. So for the second term of the sequence, that's the domain, the range is the sequence number. So 2, 5 is my next point. All right, so A3 would be 2 times 3 plus 1, which is 7. So that would be the point 3, 7. Okay, your domain is your term number, your range is the sequence number. Okay, so first term, second term, third term, and then this is the value of the terms of the sequence. Okay, so first of all, we can eliminate immediately number 1 and number 2 because of this. This right here, where does the sequence start? It starts at the first term. This is term 0. Okay, so that's term 0, not term 1. So it can't be this one, and it can't be this one. So this is not, the sequence has to start at the first term, so it's got to start at 1. So it's either got to be this one or this one. Okay, now for these points, can we do a term number that is like term 1.5? No, we can't. These are only the points that make up the sequence. These are the only points from the sequence. There are no numbers in between. So if you remember, we talked about this back in Algebra 1 a couple years ago. If these are the only points in the sequence, we can't connect the points, because if we do point 1.5, there'd have to be something in between here and here. So it's got to be number 3. This one does not include all the points between. All points between term numbers. Okay, so the answer to this one will be number 3. Okay, so that's the rest of the notes on the sequences. I guess you'll be doing your homework next.